Hey everybody, so welcome to the video. First one back from spring break. We're all super pumped, right? I'm sorry I'm not there. Babies are sick. But we're going to do this. So, when we talk about chemical reactions, we talked about a few before we left from break, and we know that this here is a chemical equation. We have the reactants on the left side, and the products on the right side. And we know there's this arrow right here means yield. So basically in this example equation, we have hydrochloric acid, HCl, plus zinc yields zinc chloride and hydrogen gas. And there's a few things in this that we need to recognize. I'm very distracted right now. Okay, so you'll first notice that there's lots of symbols in this equation, and some of them you've probably seen before, some of them you might not have noticed at all, but either way they've been there. There's this AQ, there's an S, and there's a G here. There's also this arrow. Oh gosh. Okay. So we're going to talk about what these symbols mean, because you need to know this in order to do all of the reactions that we're going to start talking about once I get back. So the first ones, these things here in the parentheses, they talk about the state of matter. Solid, obviously, everybody. Oh, I already said the word, didn't I? Whoops, S. S means solid. Solid state of matter. So we have this solid zinc metal combining with, hydrochloric acid, blah, blah, blah. G over here, everybody, hydrogen. What's hydrogen? Hydrogen is a state of matter gas. Beautiful. And I'm going to skip this arrow real quick. I'm going to jump down to AQ, and everybody should know what AQ means because we talked about it not a really long time ago, but a couple months ago. AQ means... Someone yell it out. Someone for me, for mama, yell it out. It's aqueous. And what does aqueous mean? Dissolved in. Yell it out. Thank you. It's water. All right. So aqueous means dissolved in water. So basically hydrochloric acid, we took it as a solid, we dissolved it in water, and now it's aqueous hydrochloric acid. It's what everyone's familiar with. It's just we don't realize that it's actually a solid dissolved in water. And then we have an L. Hopefully that's obvious. We have a solid, we have a gas, and we have a liquid. All right, so I'm going to go back to this arrow here. So up on this side, this orange arrow, so we know that hydrogen is a gas. Obviously, it has this G here. And if we had an open system, meaning if we did this reaction in real life, like right in front of us, we would have this hydrogen gas. It would be produced. And what happens to a gas in an open system? Well, it gets released. It goes into the environment. It goes into the surroundings. And that's what that arrow means. So basically, it was a gas that was released to its surroundings. And that's what that arrow means. All right. So we have a couple special ones down here. So that's it for this particular reaction. We have the states of matter, we have the gas, and that's what we're going to see for the most part. These down here are specific symbols that can mean very specific things for different reactions. So first one right here. We have an arrow, and normally this arrow means yield, and it's going back and forth. So hopefully you can assume, based on your prior knowledge, that it's a reversible reaction. Basically, it's in equilibrium. It goes forward and it goes backward so that the products equal the reactants. Again, think about that. It's not exactly the same, but it's kind of like the conservation of mass. It's going to go back and forth, and it has to do with Le Chatelier and his principles, and that's a whole nother story. But basically, it's in equilibrium. which means that the reactants are the same as the products. There's the same quantity. It creates products and it goes and, goes back to the reactants. It's a reversible reaction. So let's put that in parentheses here. Reverse. I don't know how to spell reverse reaction. That's what we're going to go with. There we go. All right. So now here we have our yield sign. We know that the arrow means yield. And we have, pardon me. Goodness gracious. I'm yawning. Okay. So we have this yield arrow and we have symbols above it. And I do believe, nope, I didn't in that one. But basically anytime there's a symbol above the yield arrow, it means that there's a catalyst. So down here, I'm going to write catalyst. And a catalyst, with a T, increases the rate of a reaction. So in real life, think about that hydrogen peroxide. Think about the stuff that mama and papa pour in your boo-boos and it gets all bubbly. Think about the bottle that comes in. It comes in a very dark brown bottle that no light can get into. And that's because hydrogen peroxide is H2O2. And if it's exposed to light, the light acts as a catalyst and it increases the, basically the decomposition of it, which we'll talk about later. But it increases the reaction. And obviously there's an expiration date on hydrogen peroxide. So eventually it's going to, do that on its own, but light acts as a catalyst. And so we have other things like light that can act as a catalyst. And here in this first one, I hope you all remember what this triangle means. Triangle normally means delta. Delta means change, but in this case, delta, for whatever reason, I don't know, I didn't make it up, I just follow the rules, means heat. Heat was used as a catalyst. And so anytime you see something above that yield arrow, it's going to mean that, something was used as a catalyst. In this case, delta means heat. PT, hopefully you recognize that symbol. That's platinum. That's the element platinum. A lot of times chemicals or, elements can be used as a catalyst and they don't take part in the reaction itself. They just they show up, they make the chemicals do what you want them to do, and then they, separate themselves. So in this case here, platinum was used as a catalyst. So just, quotes. So we can look at a chemical reaction. We can know a lot more than just what goes into it and what comes out of it. By looking at the symbols and the things that are involved. And we're going to talk, a lot more about these things, especially once we get into actually predicting products and the types of reactions that we're going to see. So hopefully this gave you guys a little bit of insight. And when I get back, we are going to, dive into the types of chemical reactions that we're going to see, and we're going to do some experiments and we're going to have some fun. So hopefully you guys are good. Let me know if you have any questions, and thank you very much.